Welcome to another lecture on signal and system. So today we are going to solve some problems related to Z transform. So let us solve this problem. So the problem is the xn is provided and it is equals to 1 by 3 raised to the power n un plus 1 by 2 raised to the power n u minus n minus 1. So xn is given in the paper in the question. So let us solve this problem. The question is find xz. The question is find xz. So let us solve this problem. So xn is given, so we can write xn as x1n plus x2n. So what is x1n? So x1n is 1 by 3 raised to the power n un. And what is x2n? So x2n is 1 by 2 the power n u minus n minus 1. So that if it is take the z transform, then xz is equals to x1z plus x2z. So if we take the z transform on both sides, then it is equals to xz is equals to x1z plus x2z. So okay, so let us discuss this problem. So x1n is 1 by 3 raised to the power n un. So if we find out the z transform of this signal, then xz is 1 divided by 1 minus 1 by 3 z inverse. So it is just similar to the problem we have solved, that is we have xn, that is a raised to the power n un, and the z transform is 1 divided by 1 minus a z inverse, and the ROC is ROC is that modulus of z is greater than modulus of a. So this is the ROC. So this relation we can use here. So here a is equals to 1 by 3. So we are getting this, and that ROC is modulus of z greater than 1 by 3. Now so this is x1z. So this ROC is, we have circle of radius 1 by 3, and the ROC is modulus of z greater than 1 by 3. So that is exterior, to this circle. That is exterior to the circle. So let us discuss another signal, that is xn is equals x2n is equals to 1 by 2 raised to the power n u minus n minus 1, then x2z. So if we remember, if we have xn is equals to minus a raised to the power n u minus n minus 1, then xz is 1 divided by 1 minus a z inverse, and the ROC is modulus of z is less than modulus of a. So this is our ROC if we remember. So x2z is 1 divided by 1 minus 1 divided by, so here we have minus, we have to take minus here because that minus sign is not there. So minus 1 divided by 1 minus 1 by 2 z inverse, and the ROC is modulus of z is less than 1 by 2. So we have a circle. And this is 1 by 2, and the ROC is inside that circle. The ROC is inside that circle because it is a anti-causal signal. So that ROC is basically the interior of the circle. The ROC is interior of the circle. Modulus of z is equals to 1 by 2. So the ROC is basically the interior of the circle. Modulus of z 1 by 2. Now if we find out the common ROC, because for existence of for existence of Z transform of xz, x1z and x2z, Z's ROC should overlap. So it means basically common ROC is required. Now if we just see the ROC, so we have 1 by 3. We have 1 by 3 and that is the causal, and another one is 1 by 2, another circle is 1 by 2. So if we see that first is modulus of z greater than 1 by 3, so this is the ROC of x1z, and second is that modulus of z is less than 1 by 2, and that is for x2z. So if we see that the common ROC is this big ring, is this annular ring. This annular ring is the common ROC. So we have ROC is in between 1 by 3 is less than modulus z less than 1 by 2. So this is our common ROC, that is 1 by 3 is less than modulus z less than 1 by 2. So this is the ROC of z. This is the ROC of xz. And what will be the Laplace z transform? So that xz is equals to 1 divided by 1 minus 1 by 3 z inverse minus 1 divided by 1 minus 1 by 2 z inverse, and this is our z transform. This is our z transform xz. So let us discuss another problem based on these results. So we have xn, the same problem but the treatment is different. So we have xn is equals to 1 by 2 raised to the power n un plus 1 by 3 raised to the power n u minus n minus 1. Now just we have changed these values. In previous example we have 1 by 3 here, and then in this example we have 1 by 2 here with un. So find xz. So the solution of this problem is, first we need to write this xn in the form of x1n plus x2n. So what is x1n? So x1n is 1 by 2 raised to the power n un, and what is x2n? So it is equals to 1 by 3 raised to the power n u minus n minus 1. Now let us find out the z transform of xz. So z transform of xz is equals to x1z plus x2z. Now what is x1z? So x1z is 1 divided by 1 minus 1 by 2 z inverse, and the ROC is modulus of z greater than 1 by 2. So there is a circle of radius 1 by 2 and the z transform is modulus of z greater than 1 by 2. So the ROC is like this, and second is x2z, and it is equals to that z transform is equals to minus 1 divided by 1 divided by 1 minus 1 divided by 3 z inverse. So this is modulus of z less than 1 by 3. So this is the z transform. Now if we see that, so this is 1 by 3 and this is the ROC for this signal, this is the ROC for this signal, and this is the ROC for this signal. Now we can we find out the common ROC? So if we draw that, then 1 by 3 is inside circle and 1 by 2 is outside circle. So the common ROC, so this is a ROC R1, this is ROC for x1z, so this is ROC of x1z. Second is, this is ROC of x2z, so this is ROC of x2z. Now if we carefully see the ROC, then we can find out that there is no overlapping. If we carefully see that there is no overlapping, there is no common ROC, there is no common region of convergence. It means the Z transform is not possible. It means the Z transform is not possible because there is no common ROC, so the Z transform is not possible. So let us discuss another problem. So let us discuss another problem. So the problem is we have xn and that is equals to a raised to the power n un. The xn is given a raised to the power n un plus a raised to the power minus n u minus n minus 1. So let us discuss this problem and find out the Z transform of this problem. So find out the problem. The problem is find out the Z transform of xn. So the problem is find out the Z transform of xn. Xn is written as a raised to the power n un plus a raised to the power minus n u minus n minus 1, that is equals to x1n plus x2n. So xn is a combination of x1n plus x2n. So what is x1n? So x1n is a raised to the power n un. And what is x2n? x2n is a raised to the power minus n u minus n minus 1. So we can plot first. We are going to plot xn for for various values of a. So let us plot xn when we have 0 is less than a less than 1. So when we have 0, when the a is between 0 and 1, so we can plot this value of xn, and the plot is like this. The plot is like this. So if we take another case, that is if a is greater than 1, suppose a is greater than 1, then the plot of xn is different. The plot of xn is different and the plot is like this. The plot is like this. So this is xn when a is between 0 and 1. This is xn when a is between when a is greater than 0. Now we can find out the Z transform. So the Z transform xz is equals to the Z transform of x1z plus Z transform of x2z. Now x1n is equals to a raised to the power n un. So the Z transform, that is x1z, it is equals to 1 divided by 1 minus az inverse and the ROC is modulus of Z greater than modulus of A. And another case is we have x to n, another signal is x to n, and it is a raised to the power minus n, u minus n minus 1. So the Z transform x to z is basically the x to z is equals to, if we find out, we can write it in this manner. We can write it as minus 1 raised to the power n, u minus n minus 1. So the Z transform in 1 minus 1 divided by 1 minus A inverse Z inverse. And the ROC is modulus of Z is less than A inverse. This is the ROC. So in short, we can write it as modulus of Z is less than 1 divided by modulus of A. So this is the ROC for this signal, and this is the ROC for this signal. This is the ROC for this signal, and this is the ROC for this signal. So basically this is causal. So this is causal. This is causal signal, and this is non-causal signal. This is non-causal signal. So we have different ROC for causal signal, and we have different ROC for non-causal signal. We have different ROC. Now consider the case. Now consider the case when we have the value of A is between 0 is less than A less than 1. So we have two ROC. First ROC is modulus of Z greater than A, and another ROC is modulus of Z is less than 1 divided by modulus of A. So let us plot these ROC and find out is there any common ROC between them, because if there is no common ROC, we can consider the case that 0 is less than A less than 1. If there is no common ROC, then the Z transform will not be possible. So first case is A is less than 1. So let us take an reference circle, that is unit circle. So this is our unit circle. Now A is less than 1, so A is inside that. So this is A, and 1 by A should be outside because A is less than 1. So 1 by A should be outside. So for example, is A is 2, 1 by 2, then it is less than 1, and 1 divided by A, that is 2, so it is greater than 1. So first ROC is modulus of Z greater than A. So the first ROC is modulus of Z greater than A, means it is going exterior to that circle. It is going exterior to that circle. And the second ROC is modulus of Z is less than 1 by A. That is interior to the circle. That is interior to the circle. Now if we see the common ROC, then the common ROC is annular ring. So there is a ring. So there is a ring, annular ring, and this is the common also. This is A, and this is 1 by A, and this is unit circle. This is unit circle. So the common ROC is basically, this is the ring. So this is the common ROC. This is the common ROC. Now, so it is between A is less than modulus of Z is less than 1 divided by A, modulus of A. So this is the common ROC. So this is the ROC of XZ. This is the ROC of XZ. Now, so what is the Z transform if we are taking this ROC? So the Z transform is combination of x1z and x2z. So it is 1 divided by 1 minus AZ inverse plus minus 1 divided by 1 minus A inverse Z inverse. So, and the ROC is A is less than modulus of Z less than 1 divided by modulus of A when A is between 0 and 1, when A is between 0 and 1. Now let us take the another case. Let us take the another case when we have a greater than 1. So what will happen when a is greater than 1? So let us consider that case. So case 2 is when we have a greater than 1, then modulus of z greater than modulus of a means you have unit circle, and a is greater than 1, so that circle is somewhere outside that. So it is the ROC for x1 z. And second is we have modulus of z less than 1 divided by modulus of a, so this is the unit circle. So 1 by a should be less than 1, so this is 1 by a and this is the unit circle. So the ROC is basically in ROC is basically interior, that interior of this is the ROC. So basically we see that there is no common ROC, there is no common ROC. So this is A and this is 1 by A. So no common ROC. So XZ not possible. In this case XZ not possible. So let us summarize again this course problem, because this problem is very interesting. So we have xz is equals to x1z plus x2z, and x1n is equals to a raised to the power n into un, and that z transform is modulus is 1 divided by 1 minus a z inverse, and it is that ROC is modulus of z greater than modulus of z greater than modulus of a. So we have another signal. We have another signal that is my a raised to the power minus n u minus n minus 1. So that is we can write it as my a inverse raised to the power n u minus n minus 1, and this x2z is minus 1 divided by 1 minus a inverse z inverse, and this ROC is modulus of z less than 1 divided by modulus of a. Now we can plot this ROC and we can find out is there any common ROC. So for case 1 we plot that for case 1. So we can see that when a is between 0 and 1, then that modulus of z greater than a is nothing but it is less than that circle is basically the area should be less than unit circle area, and another is we have modulus of z is less than 1 divided by a, so that circle area is bigger so than unit circle area. So now we see that it will form a ring type structure. That ROC will form a ring type structure. So this is the ROC annular ring. So this is basically annular ring. So this is the annular ring type. Now if we see the another case, that is when we have a greater than 1. So when we have a greater than 1, so what will happen that we are not getting any common ROC. So when we have a greater than 1, so we are not getting any common ROC. So here we have modulus of z greater than modulus of a. Now since a is greater than 1, so that area is basically modulus for area of modulus z is equals to modulus of a. The circle of area is bigger than is this larger than this unit circle area, and this is the ROC. This is the exterior because this is a causal signal, and here we have non-causal signal. So this is the interior, and of course there is no common ROC. So the Z transform when we have a greater than 1, the Z transform is not possible. So this is the summary of this problem. Let us do another problem. The problem is verify the time shifting property. So verify the time shifting property verify the time shifting property, that is xn minus n naught is z raised to the power minus n naught into xz, and that r dash belongs to r intersection of 0 is less than modulus of z is less than infinity. So let us solve this problem. So according to the definition of Laplace transform, if we have xn, then the z transform is n is equals to minus infinity to plus infinity xn z raised to the power minus n. Now if we take xn minus n naught, then according to this definition we have n is equals to minus infinity to plus infinity x n minus n naught z raised to the power minus n. So if we replace n minus n naught, so let n minus n naught is equals to k, then what we will get? We will get here xk z raised to the power. So it is when we have n is equals to minus infinity, then we have also that summation limits, that upper and lower limit will be the same. So it is xk z raised to the power minus, instead of n we are just writing k plus n naught. We are writing k plus n naught. So what we will get here, n is equals to minus infinity, k is equals to minus infinity to plus infinity xk z raised to the power minus k z raised to the power minus n naught. We can obviously, it is independent, so we can obviously put z raised to the power minus n naught outside. So it is k is equals to minus infinity to plus infinity xk e raised to the power minus k. So it is nothing but the z transform of simply xn. So it is simply the z transform of xn. So the z transform of xn minus n naught is z raised to the power minus n naught into xz. So this property is proved. This property is proved. And of course that ROC should be, so the ROC should belongs to R, that is the ROC of xn. So xn has ROCR, and it is R intersection with 0 is less than modulus of z less than infinity. So whatever is the intersection we are getting, that is the ROC of xn minus n naught. So let us take an example, then we will understand better. So let us take an example of del n minus 1. So that del n minus 1, del n has a z transform is equals to z raised to the power minus 1. So this is the z transform of del n. Now del n minus del n, this is the z transform of del n. Now what is the z transform of del n minus 1? It is summation n is equals to minus infinity to plus infinity. So it is z raised to the power minus 0, that is equals to 1. So del n minus 1 is n is equals to minus infinity to plus infinity del n minus 1 z raised to the power minus n. Now it is equals to summation n is equals to minus infinity to plus infinity del n minus 1 z raised to the power minus 1. So z raised to the power minus 1 put outside, we can put outside, it is n is equals to minus infinity to plus infinity del n minus 1, and that summation is obviously equals to 1. So it is 1 by z. Now what is the ROC for this? So the ROC is entire z plane. Entire z plane. The ROC of del n, so very important point. Very important point. So the ROC, so it is very important point. ROC of del n is 1. del n is basically entire z plane. The z transform of del n is 1, and that ROC is basically it is entire z plane. But the ROC of del n minus 1, if we see that, so that xz we are getting is equals to 1 by z. So z is equals to 0 will produce xz tends to infinity. So basically what we are getting, so we are getting the intersection, we are getting the intersection. So this is our z, this is our z plane, this is our z plane. So this is our z plane, but there is a point, there is a pole at z is equals to 0, and at that pole the ROC at that pole, because the ROC will not contain any pole, so we have del n minus 1. So this is xz is equals to 1 by z. So z is equals to 0 will make xz tends to infinity. It means that we should avoid the pole, because the ROC, because since the ROC does not contain any pole, since the ROC does not contain any pole, and that the ROC of del n minus 1 is entire S plane. Now there is so what is the intersection? Entire x plane except z is equals to 0. So what is the intersection of ROCs? So the del n has ROC R, that is entire z plane, and del n minus 1 have ROC R dash, that is entire z plane except z is equals to 0. So what is the intersection? So R intersection R dash is equals to the ROC of del n minus 1, that is what is the ROC of this, basically that ROC of del n minus 1. So the ROC of del n minus 1 is basically R intersection with the points, that is z should not equals to 0. Let us do another problem. So the problem is, okay, we can further see there is an important point. So because what is happening, that if we see that problem, that x n minus 1, that due to this there is delay here, so we are getting z raised to the power minus n0 into xz, and the ROC is basically that R dash is basically R intersection with 0 is less than modulus z less than infinity. So the important point is that we can see that because of the multiplication, so we can see that because of the multiplication, we can see that there is a multiplication of z raised to the power minus n0 here. So xn has z transform xz. Because of the multiplication by z raised to the power minus n naught for n naught greater than 0, additional poles are introduced for z is equals to 0 and will be deleted at z is equals to infinite, and will be deleted at z is equals to infinite. So therefore the point, we can see that therefore the point z is equals to 0 and z is equals to minus infinity, z is equals to infinity, can be either added, can be either added to or deleted from the ROC by time shifting. So we can further summarize that xn minus n naught has z transform that is equals to z raised to the power minus n0 into xz, and the r dash belongs to r intersection with 0 is less than modulus z less than infinite, where r dash and r are the ROC is the ROC after and before the time shift operation, before and after the time shift operation. Now let us do another problem. So the problem is verify that z raised to the power 0 z0 raised to the power n xn, the z transform is equals to xz divided by z naught, and the ROC is basically r multiplied by z naught. ROC is r multiplied by modulus of z naught. So let us solve this problem. Let us verify this problem. So basically, if we have xn, that z transform of xn is summation n is equals to minus infinity to plus infinity xn z raised to the power minus n. So if we find out the z transform of z0 raised to the power n xn, then it is nothing but n is equals to minus infinity to plus infinity z0 raised to the power n xn z raised to the power minus n, and that is equals to summation n is equals to minus infinity to n is equals to plus infinity. That these two terms we can combine together, and we can find out that we have z0 raised to the power n z minus n xn. Now what we can do here, we can find out that it is nothing but xz divided by z naught. It is nothing but xz divided by z naught. And if we find out the ROC, then the ROC is basically, so this has ROC, this signal has ROC R, then this ROC of this signal, that is R dash, and it is equals to z naught, that is magnitude of z naught multiplied by r. So this is the new ROC. Let us do some problems. So the problem is we have xn, find out the z transform of del n minus n naught. So the z transform is basically z raised to the power minus n naught. So, and the ROC, what is the ROC? So the ROC is basically 0 is less than modulus of z and n naught is greater than 0 when we have n naught greater than 0. So this is the ROC. And second case is there when this is modulus of z less than infinity, when n naught is less than infinity. So this is the second ROC. So it depends on the value of n. So if n naught is equals to 1, that is n naught greater than 0, then xz is equals to z raised to the power minus 1. So it is equals to 1 by z. So the ROC is basically, we say that the ROC is entire z plane except z is equals to 0. So this is the case when we have n naught greater than 0. Now there is another case when we have n naught less than 0. So we can see that when we have n naught less than 0, then xz, suppose n naught is equals to minus 1, for example, then it is z raised to the power minus of minus will become plus, so it is z raised to the power plus 1. So the ROC is basically that entire z plane except z is equals to infinity, because when we put z is equals to infinity, the same signal, this signal will become this xz will become unbounded. Here when we will put z is equals to 0, this will become unbounded, this 1 by z will become unbounded. So when we have n naught greater than 0, then basically we are just excluding 0. We are basically that excluding 0. And when we have n naught less than 0, then basically we are excluding infinity. So we are excluding infinity. So it is entire z plane excluding infinite. Here it is entire z plane except 0. So when we have n naught greater than 0, we are excluding 0. When we have n naught less than 0, this is less than 0. So when we have n naught less than 0, we are excluding infinite. Let us do another problem. The problem is we have xn that is equals to u n minus n naught. So xn is equals to u n minus n naught. Now the z transform is summation n is equals to minus infinity to plus infinity u n minus n naught z raised to the power minus n. So n minus n naught we can put k. So here we are getting k is equals to minus infinity to k is equals to plus infinity uk z raised to the power minus n naught plus k. So that is equals to k is equals to minus infinity to plus infinity uk z raised to the power minus k z raised to the power minus n naught. Now we can see that xk is z raised to the power minus n naught summation k is equals to minus infinity to plus infinity uk z raised to the power minus k. And so here we can see that from k is equals to 0 to infinity only, this uk is equals to 1, so it is z raised to the power minus k. Now the solution is the solution of this problem is z raised to the power minus n naught, and basically this is a This is a form of GP. So it is 1 divided by 1 minus Z inverse. This is the solution. So now again we see that we have poles. So xz is z raised to the power minus n naught divided by 1 minus z inverse. So this is the solution. This is the Z transform. Now what is the ROC for that? So the ROC basically if we consider n naught greater than 0, then what we will get here, greater than 1. If we consider n greater than 1, so what we will see here, that this z raised to the power minus, suppose this is z raised to the power minus 2, minus 3, minus 4, all these things. So what is happening, that it is for example, if n is equals to 2, then we are getting z raised to the power minus 2 divided by 1 minus 1 divided by z. So we can further write it as z raised to the power minus 2 divided by z minus 1 divided by z, and we are getting z raised to the power minus 1 divided by z minus 1. So it is equals to 1 divided by z minus 1. So we have poles at z is equals to 0, and we have poles at z is equals to 1. So we are going to, because we have poles at 0 and 1, and since it is a causal signal, so the ROC should be exterior to that maximum magnitude pole. So that what is the ROC we are getting? So we have the 0 here and we have 1 here. So the ROC is this exterior. So that ROC for this signal is 1 is less than modulus of z less than infinity. This is the ROC we are getting. This is the ROC of this signal. So un minus n naught, the z transform is z raised to the power minus n naught 1 minus z inverse, and the ROC is 1 is less than modulus of z less than infinity. The ROC is 1 is less than modulus of z less than infinity. So because the ROC will not contain any pole, and it is basically that causal signal. It is a causal signal, so that ROC will be exterior to that circle modulus of z is equals to 1. Let us solve another problem. So let us solve the problem. The problem is given as the xn is provided in the question. It is equals to a raised to the power n plus 1 un plus 1. So here we can use that property. So which property we are going to use? We are going to use the property that when we multiply some multiplication of z raised to the power minus n naught with xz, if we find out the inverse Laplace transform, then we will get x minus n naught. Now if we just multiply with z raised to the power n naught with xz, then the inverse Laplace transform will give us n plus n naught. So we can use this relation. In this. So we have x1n, that is equals to a raised to the power n un, and the z transform is x1z, and that is equals to 1 divided by 1 minus a z inverse, and the ROC is modulus of z greater than modulus of a. Now if we take another signal, that is a n plus 1 un plus 1, it means the z transform of this signal, if we just use this relation, then what is n naught? So n naught is nothing but 1. N naught is nothing but 1 here. So we have z we have z multiplied by 1 divided by 1 minus a z inverse. That is the z transform of a n plus 1 u n plus 1. That is the z transform. So we can further simplify it as z square divided by z minus a, and the ROC is between modulus of a is modulus of z is less than infinity. So this is the ROC. This is the ROC. So basically that a raised to the power n plus 1 u n plus 1, the z transform is nothing but z square divided by z minus a. Z square divided by z minus a, and the ROC is modulus of a should be less than modulus of z, and that should be less than infinity. So this is our solution. So we have used this property. We have used this property that when we apply z raised to the power minus n naught with xz, the inverse Laplace transform of this is xn minus n naught. Now if we applied it with xz with z raised to the power n naught, then the z transform will be xn plus n naught. The inverse z transform. The inverse z transform will be xn plus n naught. Let us do another problem. The problem is find out the z transform of x minus n. Find out the z transform of x minus n. So that z transform of x minus n, and if xn is given, if xn is un, if xn is given as un, then find out z transform of x minus n. So the solution of this problem is, so x minus n is nothing but u minus n, and we can apply the time reversal property. So according to this property, if we find out, if we see the time reversal, then if xn has z transform xz, then x minus n should have the z transform x1 divided by z. This is the time reversal property. And the ROC, if the ROC is R, then the ROC of this is 1 divided by R. The ROC of this is 1 divided by R. So what is the solution for this problem? So if xn is equals to un, then the z transform is 1 divided by 1 minus z inverse, and the ROC is modulus of z greater than 1. So now we have x minus n, that is u minus n. So the z transform of this is simply, this is x dash z. So it is simply 1 divided by 1 minus, just replace z with 1 by z. So it will become z only. And what is the ROC? So the ROC is now 1 divided by r, means the ROC is now modulus of z less than 1. Now the ROC is modulus of z less than 1. This is our ROC. Previously the ROC is modulus of z greater than 1 for this signal when you have xn is equals to un. Now when we have the time reversal, then the z transform is 1 divided by 1 minus z, and the ROC will get the inversion. The ROC will get inverted. So it is modulus of z less than 1. Let us solve another problem. So let us solve another problem. So xn is equals to a raised to the power minus n u minus n. Let us find out the z transform of this signal. So let us find out the z transform. So it can be written in this form: xn is equals to a raised to the power minus n u minus n. So it is basically if we have x1n, if we consider x1n is equals to a raised to the power n un, and the z transform is x1z, and it is equals to 1 divided by 1 minus a z inverse, and the ROC is modulus of z greater than modulus of a. Then if we take the time reversal, then xn is nothing but x1 minus n. So xn is nothing but it is equals to x1 minus n. So the z transform of this xn is xz, it is denoted by xz. So it is we are considering the time reversal. Since we are considering the time reversal, so the z transform should be 1 divided by 1 minus, instead of z we are just replacing with 1 by z. So it will become 1 divided by 1 minus az. And the ROC will be modulus of z is less than 1 divided by modulus of a. So here we have ROC r, here we have ROC r dash, that is equals to 1 by r. That is, we are applying the time inversion here in the ROC. So it is modulus of z is less than 1 divided by modulus of a. So this is the z transform of a raised to the power minus n u minus n. Let us do another problem. Let us do another problem. So the problem is verify the multiplication by n property. Multiplication by n property. So what is multiplication by n property? If xn has z transform xz and ROC is r, then nxn has the z transform minus z dxz divided by dz, and the ROC is r dash, and that r dash is equals to r. So let us solve this problem. So we have xn. Let us solve this problem. We have xn. The z transform of xn is summation n is equals to minus infinity to plus infinity xn z raised to the power minus n. So it is equals to xz. So xz is equals to minus infinity to plus infinity xn z raised to the power minus n. Now we can differentiate both sides. So differentiating both sides with respect to z, we get dxz divided by dz is equals to summation n is equals to minus infinity to plus infinity xn, and we are getting here minus n z raised to the power minus n minus 1. So what we are getting here? We are getting here summation n is equals to minus infinity to plus infinity n xn z raised to the power minus n z raised to the power minus 1. So this z will means transfer here in left hand side. So we get and also minus we can put here. So minus z dxz divided by dz is equals to summation n is equals to minus infinity to plus infinity n xn z raised to the power minus n. And so if we just analyze this expression, then it is nothing but that n xn has the z transform that is equals to minus z dxz divided by dz. Just we can see from this expression only that x and xn has the z transform, that is equals to minus z dxz divided by dz. Hence proof. So let us solve another problem. So the problem is we have xn that is equals to n a raised to the power n un. We need to find out the z transform. So find xz. So the solution of this problem is we have xn. Let x1n is a raised to the power n un. Let x1n is a raised to the power n un. Then x1z is 1 divided by 1 minus az inverse, and the ROC is modulus of z greater than modulus of a. This is the ROC. Now if we just multiply with n, this nx1, then what we will get? We will get the z transform as minus d divided by dz x1z, and the ROC will remain r. So if the ROC is r, then r dash will also remain r. So it is minus d by dz of 1 divided by 1 minus az inverse. So what we are getting finally? We are getting az divided by z minus a whole square. We are getting, and the ROC is modulus of z greater than modulus of a. So we are getting az divided by z minus a whole square, and that ROC is modulus of z greater than modulus of a. That is the same one. The ROC will remain unchanged. So ROC will remain unchanged. So we have just applied the property. So which property we have applied? If xn has z transform xz, then xn nxn has z transform minus z dxz divided by dz. So we have applied this property. Let us solve another problem. So the problem is we have xn that is equals to n a raised to the power minus n un. So we need to find out the z transform of this problem. So the problem is n a raised to the power n minus 1 un. So xn is provided, that is an minus 1 un. So we need to find out the z transform of this signal. Now we know that the z transform of a raised to the power n un is 1 divided by 1 minus az inverse, and the ROC is modulus of z greater than modulus of a. This is the ROC. Now differentiating with respect to a on both sides, we get n minus 1 un, and that is the z transform, basically d by da of 1 divided by 1 minus az inverse, and that is equals to z divided by z minus a whole square, and the ROC is modulus of z greater than modulus of a, which is the same. So we can apply simple mathematical tools to find out the z transform, of these type of signals. We can just apply the simple mathematical tools to find out the z transform. So the z transform of n minus 1 un is nothing but z divided by z minus a whole square, and the ROC will remain same. This is the ROC of a raised to the power n un, that is modulus of z greater than a, and the same ROC we are getting here. The same ROC